students. Our topic today is electromagnet and the applications of electromagnetic field. An electromagnet consists of a soft iron core in a current carrying solenoid. As the name implies, electromagnet contains two things in one. Number one is electric, number two is magnetic field. The magnetic field strength due to such a solenoid is increased by presence of the soft iron core or rod within the solenoid. When you place the soft iron core inside the solenoid, a wound round wire and the current is allowed to flow through it, the solenoid itself produces a magnetic field around it, and at the same time the soft iron core inside they also produce a magnetic field. So when you combine these two together, you have a stronger magnet. An electromagnet is a temporary magnet. An electromagnet can be made by winding the cores or solenoid in opposite direction round the two arms P and Q of a U-shaped iron core or a bar shown below. When you look at the diagram below, you see U-shaped soft iron core and a wire is wound around it. The direction of the wire determines the side of the north and south pole. The current, the place where the current is coming from, represent the north, while the place where the current is going in represent the south of the U-shaped magnet. The wires are connected to the battery, the resistor, and the switch in order to control the amount of current going in. When current flows from a battery round the solenoid, it is observed that the end P acts as a south pole and the end Q acts like a north pole. Such an arrangement produces a strong magnetic field. However, magnetization and demagnetization occurs rapidly when the current is switched on and off. Hence, electromagnets are temporary magnets. Electromagnets found many common applications in industry, such as number one, in producing intense magnetic fields such as those required in generators and electric motors. It can also be used in lifting and transporting heavy pieces of iron and steel, e.g. steel plates, girders, scraps, irons. They can be used to separate iron from mixtures containing non-magnetic substances. And number four, they are used in construction of such electromagnet devices as the electric bell and the telephone earpiece. Now let's talk about temporary magnets. Temporary magnets are magnets made from soft iron bars or metals, and can only retain their magnetization when placed near a permanent magnetic field or electric current. A common temporary magnets include nails and paper clips, which can be picked up or moved by a strong magnet. The electric bell. The diagram you see above and you are seeing on the screen is the diagram of an electric bell. If you look at this diagram, you have three ions. Number one is soft iron yoke. As you can see, it does not carry any wire. Number two is soft iron. Number two is soft iron core, and the third one is also soft iron core. A soft iron core. Then these two soft iron core are around it. We wind wire around it in order to produce a solenoid. Once wire is wounded around this soft iron core, they become magnet as soon as the current is switched on. Now the wire is connected to a spring contact point, and also the spring contact point is connected to soft iron armature. The soft iron armature carries a clapper. That round thing you see there is called a clapper. Then from there you have a spring contact and a spring contact and adjusting contact screw. So once the current is switched on and the circuit is complete, the clapper moves electrically. Immediately the current switched on, the two soft iron becomes magnet, and they will attract the clapper. When they attract the clapper come and strike the gong, and immediately the clapper strike the gong, the current, current is AC current, which is alternating current. The current goes on and off. So as the current goes off, the clapper returns to its position. Then when the current come on again, the electromagnet becomes magnet, and they attract the clapper again to strike the gong, and this happen within seconds. So automatically this process will be repeating itself. So working principle of this: when the bell push when the bell pushed is pressed, the bell push, that means the switch, the circuit of the system is completed and current flows around the electromagnet. The soft iron core becomes magnetized, and the electromagnet attract the soft iron armature attached to the spring. This makes the clapper to strike the gong. The circuit is broken as soon as the spring moving away with the soft iron armature breaks contact at sea. As soon as this happens, the electromagnet loses its magnetism, and therefore it attracting force in on the armature. This armature now flies back to the force of this armature now flies back to the force of the spring to remake contact once again, and then flies through the electromagnet once again. The sequence the sequence of this event is repeated rapidly, and the bell continues to ring as long as the bell push is pressed. The instruction works in a make and break device. The instrument works on a make and break device. Now let's talk about telephone earpiece. The telephone earpiece is a device which converts the varying electric energy from the microphone into varying sound energy. The component parts consist of: number one, the speech coil wound in opposite direction round the two soft iron pole pieces A and B, placed respectively at the south and north end of a permanent strong magnet M. A soft iron spring diaphragm alloy made of magnetic alloy and located in front of the iron core. You can see the diagram up here. You have M, which is the permanent magnet. Then you have A and B. The difference between these is that the telephone earpiece and the electric bell. In electric bell, there is no permanent magnet, but in telephone earpiece is a permanent magnet. Then you have two soft iron core around which wire is wound round. Then you can see the diaphragm in front. Now, working principle of this: when a caller speaks into the microphone at the other end of the communication line, the varying sound energy from his speech is converted into a varying speech current. The varying sound is converted to varying speech current, which is transmitted into the earpiece at the receiver's end. The variation in the electric current due to changes in the speech energy causes a variation in the magnetism of the electromagnet. This varying magnetism of the electromagnet causes vibrations of the diaphragm in front of the vibration of the in front of it full stop. Vibration of the diaphragm creates sound waves of the same frequency in the air as the speech current full stop. Hence, the speaker at the other end is heard. That'll be the end of the class. So we'll be going into week 7.